All right, everyone, let's get the show started. My name's Eric Osterman, and today is November 17th, 2021. Welcome to our DevOps office hours. I'm the founder and CEO of Cloud Posse. We're a DevOps accelerator. That means that we help companies own their infrastructure in record time by building it together with your team and showing them the ropes. So if that sounds interesting, head over to cloudposse.com/quiz to get started. For those of you new to the call, the format is very informal. My goal is to get your questions answered. So feel free to unmute yourself at any time if you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by heading over to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. We host these calls every week. Our call today is recorded. We'll automatically post a video recording of this session to our YouTube channel so you can, enjoy it and share it with your team. And if you haven't already, hit those like and subscribe buttons on our YouTube channel. That'll help us out a great deal. Thank you. So let's kick this off. Got a number of announcements here. This one here, I'm bringing this up not for so much the fact that it happened that that booking.com was hacked, and unfortunately these sorts of announcements seem far too frequent these days. I think the bigger point about bringing this up was how sometimes I hear companies say that we're not too concerned about getting hacked, we just sell books or something, or in this case, we're not that, all we do is bookings. I'm not saying anybody ever said that, but sometimes we minimize the impact of what we do because it doesn't seem mission critical. So in the sense of selling online greeting cards or something, it doesn't sound like it could be anything nefarious that could be used for, but it actually can. And that's what was shown with this hacking attempt, that it was actually hacked possibly by a US intelligence service for the purpose of tracking hotel stays of where people were traveling overseas, so that they could maybe, for example, plant bugs in the rooms of guests that they wanted to do. So that's a pretty interesting attack vector, and it shows that even if you're selling just hotel bookings, security is a big concern. Especially for the patrons of the service. Next up is a similar hack. This one turns out to have been caused by some poor web-based form that allowed the attacker to generate arbitrary text emails and send them out. What I thought was interesting about this was the creative writing that was used in the spam messages that were being sent out to people who got hit by this. So imagine, it's a person like one of us. If Cloud Posse, if I got an email like this, I would have been initially very suspicious of it because of the formatting being just pure plain text. But then I would have gone to look at the headers, and sure as SHIT, it was coming from an official FBI host, and that can't be spoofed. You can spoof like the from email very easily, right? But you can't spoof the email delivery chain. So here's this email coming from an FBI server with this message. I would have been, pretty concerned, to say the least. So yeah, I guess this has been addressed now.
And it doesn't look so unnatural for FBI to use plain text, right?
I haven't gotten too many emails from the FBI, so I don't know.
I mean,
so
for me, it just makes it more legit.
Yeah.
They are too serious to make you any footers or headers.
Although if you're a native English speaker and you read this message, there are lots of grammatical errors and things along those lines that I'm sure the FBI would not allow to be sent out in that case.
Yeah.
But, it's also
a little bit weird. Stay safe. U.S. Department of that's a little weird. Yeah. The capitalization there on the dark overlord, comma, capital.
And there's no call to action or like or contact information for like the cybercrimes division of the FBI. Like if you need to get back in touch with them or anything. Like, there's a lot of things if you
there's
look
a
at
lot
this
of
and
red
you're
flags
like,
with this one here. Yeah. I can see you've taken the Mitnick's, was it Beyond, what's there?
Yeah, I don't remember the title of it, but I have participated. But unfortunately, I have corresponded with the FBI on a cyber crimes thing. But it was not of my doing. It was it was because our infrastructure was under a DDoS attack by China. Or a bunch of things in China. So we called the FBI to try to help like stop it because we couldn't get it stopped, and they were consuming like 38 gigabits per second of
the
like
Great
network
Cannon,
bandwidth,
or whatever it's called.
something like that. Yeah. So and I can tell you that the correspondence was very formal and proper.
But it's very easy to
Contact
find.
information.
It's very easy to find where it's incorrect when you already know that it was spoofed, right?
It can be a little bit like that. Sometimes in hindsight, you know, you can, here were all the telltale signs, and there's a little bit of both. So the next one is, it was brought up by one of our team members. We're doing a few Argo CD rollouts right now, so we're paying attention closely to some of these announcements. And the latest change here brings some interesting improvements to Argo CD. In, I think, Argo CD 2.1, they introduced application sets which we were using and enjoy. Now with Argo 2.2, they make it easier to configure the RBAC rules of Argo CD to empower developers to configure additional Kubernetes clusters and additional source code repositories to watch. So just improves the overall DevOps delivery of Argo CD. The other one is the ability to define kind of your own custom plugins, just calling shell scripts. So you can continue to just deliver interfaces through Argo CD that are used by your various continuous delivery systems working with Argo CD. This one here, I was really excited to, sorry, go on.
No, I was gonna say it's interesting that example they showed of using CLIs is actually doing a CDK deploy. You know, a synth. It's actually running like Amazon like CDK
that is
to
interesting.
deploy.
Yeah. No, that's a good one to point out. So this is the key thing about Argo CD, is that Argo CD is strictly only for Kubernetes, in that everything is done inside of Kubernetes by custom resources that you define there. And if you want to then have it deployed to something else, well, you still have to deploy to Kubernetes, but then rely on, in this case, Argo CD to run from within Kubernetes and then synchronize some resources to. Oh, you know what? This is different. This is CDK Kates, and I was thinking this was different. Yeah, so this is actually generating the manifests that would be synchronized by Argo CD. I was thinking this is a way of using Argo CD to deploy CDK, and I don't think that's what this is doing.
Yeah, I'm just saying. I think they're actually deploying. It's pretty interesting that they show you how to do some little hacks like this. You know, that's all. I was just pointing out that
it's great. Yeah,
the command you run is was actually interesting in this point in this example.
Yeah, not contrived. And like, and to this point, like their point is like, they natively support customized Helm and JSONet, and there's an unlimited supply of these kinds of tools out there. So this presents a generalized kind of interface to then leverage additional tools. Like if you wanted to use Helm file, you can then use Helm file then to generate the templates and cat the outputted manifests, for example, and do the same kind of deployment mechanism. So yeah, this is cool. Next up is, there's a post that was brought to my attention. I forget where now. But it's a post by an engineer at Google working on Google's Fabric. Terraform module is kind of Google's own reference architecture implementation in Terraform. And unlike Terraform AWS modules, Terraform Google modules, I believe, is actually owned and operated by the Google organization. And this is a post coming out from one of their developers. And what I like about it is it highlights a pattern that we've been using. We've been calling it just YAML configs or something. nothing too more elaborate, or our catalog, like a implementation of this is like our catalog pattern. But I think this is a better way of framing it for others familiar with the factory pattern in other languages. So here we're talking about a factory pattern for Terraform, where you can generate n number of resources without changing the architecture of your module. You just define a declarative interface in YAML, pass that to the module, and it'll pass through the factory and generate all those resources. They present a sample implementation that they're using. It seems pretty conventional in how a lot of organizations use Terraform. Broken down by folders and folders with configuration. Cloud Posse has taken a different approach to this. We are trying to use fewer folders, larger YAML configuration files to configure everything. And I wanted to highlight some examples, if this is a little bit too abstract, on what are some examples of Cloud Posse resource factories. So this is, these are some examples here of resource factories. One example here is our service control policies module, our AWS config module. And what this module does, like we take a look at the AWS config module, it implements the business logic of taking a DSL that we've defined in YAML and translating it to the underlying AWS config resources. So, fundamentally, Terraform was designed to be your record of configuration of what you wanted to have. But it's more and more morphed into a language, and those configurations are, well, far from the declarative configurations I'd like to manage on a day-to-day basis as a developer. So, hey, you could just use Terraform to manage AWS config, easy peasy. Here, this is all you got to do. You just got to write all this stuff. Or, you could implement it the way we've done it here in this module, and then you can now provide catalogs of configuration for what you want to deploy without changing a lick of infrastructure code along the way. So here's an example where Matt Calhoun on the call actually implemented our AWS config module using this pattern, a Terraform resource factory. And we've ingested the full list of AWS managed config rules into YAML here, and then we just spit those out. You as a consumer of this module have the choice of using our packaged catalog configurations, or you can bring your own. And if you bring your own, you don't need to change a lick of our Terraform code either. You just need to follow the convention, the declarative interface that we've defined for generating all these resources. Same thing goes for like our service control policies module. This is helping manage all the policies in an organization for service controls, and then providing a catalog of many of the common kinds of configurations you might want to deploy, and so forth. Any questions on this pattern? Or something you'd like to add?
It looks like a Terraform providing a template or a boilerplate, and YAML providing a content, which is.
Yeah, it basically, it lets you come up with the interface that you want to support and support unlimited possibilities of how your module is invoked. So instead of trying to parameterize the heck out of your module, just come up with a schema for it and then implement that. It's very similar to another convention that Cloud Posse has adopted, which is a convention for Helm. So for the convention for Helm, what we recommend for organizations is to develop charts as an interface. So in this case, think of your Helm charts as just a definition of how you want to deploy a microservice in your organization. And if we think about how most companies develop Helm charts, is like you have 30 microservices, now you're managing 30 charts. How are those 30 charts developed? Probably a developer just running Helm create, which generated 100, 200 lines of boilerplate code that's almost identical, that you are now committing to source control, committed to managing the tech debt across all of your 30, 40, 50 microservice repos, and they differ by like 2%. So for all intents and purposes, they're the same. So therefore, why don't we standardize the pattern, have a consistent chart for your organization that you can invest in. You can add automated tests on the chart. You can support simpler conventions for passing environment variables and ingress definitions and so forth. So that's the charts as an interface pattern.
Another example we've been discussing with Yontam is like when people want to migrate from Helm operator from a Flux CD ecosystem, we literally can do a Terraform module which accepts an exact variable format of Helm release in Flux CD, so that you can literally feed your Helm release to Terraform code and then deploy same sync with Terraform without using Flux and migrate.
Just using that schema, using the Flux schema, kind of, yeah.
Yes,
that's the cool thing about YAML. Yeah,
you can mimic your existing schemas and make your migrations easier. If you like some particular schemas, but not the products that stand behind them, you just copy the schema itself and put your own backend.
Yeah. That made me think of another example. Datadog, one of our customers said, hey, we just want to use Datadog UI, create the monitors, but we want to manage it via Terraform. So here's another simple case where you could just then do those exports. It's JSON, just write your Terraform module to consume the JSON and do the terraforming that way. What were you going to say, Matt Cullen?
Yeah, I was going to say the only caveat I'll put out there with this whole pattern that I ran into, at least on several occasions, is that Terraform isn't quite there yet with deep object validation and optional keys and all of that kind of thing. So inevitably, you're going to have to turn your input variable into like an object of any, instead of having to define a nice neat schema to it if you want this to work, which really kind of sucks. So, but I'm praying that they're going to fix it one of these releases.
Yeah. So, and I empathize with that. There's two warts with this approach. One is, to Matt's point, we finally got strongly typed variables in Terraform, and what do? We throw them away and go to YAML, and we're back to loosely typed. And it's like it's like 2 steps forward, 1 step back a little bit, and it hurts to say this. Like, I want the strongly typed. There's a lot of benefits with that. I kind of feel like it was a little too late. Like, we had to make some moves anyways, and we started adopting this pattern before. I think the support was there for Terraform on the strong types. And this also relates to the language server integrations with editors, right? That they're very good now at looking at the variables and auto-suggesting what you should type and validating it. And when you go to this format, the language server isn't really able to help out with those suggestions. So if those are...
Yeah, although if you have the right language, or not the right language server, but the right plugins, and you have a JSON schema for your YAML format, then you can get type ahead for those for sure.
So this was going to be my kind of snarky response to it was, all we need to do is therefore add a JSON schema, extend it to our YAML config module or providers that we have managed at Cloud Posse. And then we can get back some of that control. And we can actually now control the validation more so than maybe we could do with just a Terraform proper. So maybe there's some advantages to going that route. Anyways, what I'm talking about here is Cloud Posse has a provider, Terraform provider utils. And this is what we're doing to really make Terraform better at handling some of the things we want to do when working with YAML or JSON. For example, deep merging. So a JSON schema data source might not be a bad thing to add to this. So we can validate the schema matches the input at runtime. And then the most modern IDEs can look at the schema file as well, maybe, and ensure that you are not malformatting the YAML.
Yeah, like as an example, I do that with like Kubernetes, like manifests. I have a plugin that does that and tells me if makes it red right in my VS Code if it's not adhering to the latest schema, that kind of thing. So it works well.
Yeah.
But it's definitely more work for the maintainer, unfortunately.
So any more questions? Yeah, it is a little bit more upfront overhead for the maintainers to implement. And I mean, ultimately, I guess we do want HashiCorp just to come up with better validation for complex objects. Any other questions on resource factories? What problem it solves, or why you might want to do it, or?
Yeah. Do you want to dig in a little more why I would choose this? Because
yeah, go for it, Mike.
Yeah, I'm just taking a look at the service control policies repository you guys have on Cloud Posse's GitHub. Yeah. And it makes sense. And I guess the question I have is, does everything just get stored now in the code? Like,
let me give you let me give you a apples to apples comparison, I guess. I don't know if that's the right usage of the expression here, but
let's go with it.
I gotta run with it here. So back in the day, Cloud Posse was managing a Terraform module for Datadog monitors. Mm-hmm. And it looked basically like this. It was a submodule for every kind of thing we wanted to do. And let's jump in here to like containers as a service. And then, well, then there's, so maybe you're using ECS or Docker or Kubernetes. Okay, so then what are all the monitors we want to implement for that? All right, we're going to implement a bunch of monitors for the cluster. Okay, cool. So then we write the Terraform code for that. Now, first of all, look at all this overhead to define a new monitor. All this code, all the documentation for it. One can argue one thing. We can argue, well, this is testable. This is easily documented. This is opinionated. Okay, I'll give it to you. I'm not saying that this was the wrong move. I'm just saying in the end, it didn't work for us for a reason I'll show you in a second. But if we jump also into the code for a traditional Terraform module in this way, let's see here, what is it? This is what they'll look like. So they're taking a Terraform Datadog monitor, they're coming up with the query for you, they're interpolating the query and doing what you should probably, some things that are opinionated about it. And then you got a customer with slightly different requirements, or you have slightly different requirements, and this doesn't work. And now you got to clone the whole freaking repo with all those submodules to maintain your divergence of this one query because you wanted to add one more parameter, or you want to add one more label, or you want to do one little thing different. The other thing is like, it's just a lot of, it's not very dry in my book to express all of these monitors for everything you want to do with all these module definitions. It puts a lot of burden on the caller to know what all those parameters are, and keep in mind all those parameters every single time. There's no convention for those. Those were arbitrary that were developed by the developer for what those parameters are. So I can't remember, was it max threshold, or was it threshold max, or was it container max threshold, or I don't know. Maybe because you have it tightly integrated with your language server, that's not going to be a problem. So let's take a look at the Cloud Posse approach now to Datadog and how it's different. So rather than come up with 1,000 modules for every kind of situation and service we want to manage, we define what it means to implement synthetics, what it means to implement monitors, and we Terraform that out. So we've come up with our own schema. So while the module itself is, kind of almost just a proxy for YAML to HCL, it is still opinionated in how we do it. And we are able to leverage the catalog pattern or the factory pattern to work with this. So here's what that looks like then, is to define our monitors. We are building up a library of everything you need to monitor Kubernetes, for example. And what did we do? Well, we went to Prometheus operator and looked at what the community, the fine work the community has done there with Alert Manager and all the recommended monitors. And then we adapted them to the query language of Datadog. So what we have here is a perfectly parameterized list of everything we want to monitor. And this is a parameter, honestly. Like it doesn't get that much more dry than that without creating an explosion of parameters. Like we could add a variable for this, we can add a variable for max or min, we could add a variable for this, we could add a variable for this, we could add, and it's just like, at what point are we like really providing any value by adding more variables and more interpolations there? So, we expose every possible parameter then that you could possibly want to customize here. And the cool thing about YAML compared to Terraform is that YAML can be loaded at runtime. It can be pre-processed, post-processed. And that's what's nice, is that we can, when you call our module, I don't know if I have an example right here, but basically it's loading the YAML files directly from GitHub. So you can use our central library of monitors, or you can use your own catalog of monitors. I think I have an example of that in our docs.
And this, what you have in front of you, these Atlassian, I don't know how to pronounce that, is that's your internal stuff, right?
What was that?
The docs you just had up, your Atlassian docs.
Oh, the Atlassian, yeah, this is our Cloud Posse documentation for customers. Yeah, it's not open source at this time. We're mostly investing in it internally with our customers. So in this case here, you can see how in a customer implementation, you can deploy your set of monitors, referencing your local catalog of non-production alerts. And we didn't need to change a line of code in our Terraform to support all the 1,000 combinations that could exist for how customers want to monitor their stuff. So that's what we call the architecture, or the configuration of your architecture. That is what you move to YAML. Now you can write your Terraform modules as totally reusable building blocks, what we call components.
And then the idea of a catalog is just not even customizing, but just passing in parameters to those components, right?
Yeah, exactly. Pre-configurations, like you can have it, like let's say you have you have a component to deploy an S3 bucket.
Mhm.
There's 1,000 ways you might want to configure S3 buckets, but there's usually a few patterns. You want to have a bucket for logs. You want to have a class of buckets for logs. Like you have logs for your custom application. You have logs from your Jenkins server. So you have logs from other like EC2 uploads or something. And I'm making this up. You have artifact storage. You have
archetypes.
Yeah, archetypes is a good term for that. Exactly. So what we do is we use the catalog pattern to define archetypes for the kinds of buckets you want with pre-configured settings. And then anytime you want to leverage that, you just use that catalog configuration.
Okay.
So yeah, for us, catalogs are collections of shareable, reusable configurations that are typically defined in YAML and can be imported.
It's also a common way to not to repeat yourself when you have multiple accounts or multiple environments defined and they have the same implementation of something. You just put it in a catalog and then just import in all those environments so that you don't repeat yourself.
So here's an example of what that is. Yep, go on, Matt.
No, I was just going to say if Terraform were an object-oriented programming language, you would think of the catalogs as class implementations of like an abstract-based class, basically. You know, if you look at it that way, you know, like.
That makes sense.
That's a good analogy.
Appreciate that.
I should borrow that. And having those reference points, I think, is an important part for approaching these things. These are well-established patterns in other languages. Can we mock or mimic some of those patterns in what we do with Terraform? Here's an example of what I was trying to express. So you might have a file called stacks catalog S3 bucket. Now you might have different flavors of the bucket, different archetypes, to use Max's term. And then when you want to use it, you just import, hey, I want to have an S3 bucket. Bam, done. If we needed to have 10 buckets or one bucket, there's no difference. So here's an example of reusing the bucket. So here we're going to have public images, and here we're going to have private artifacts, and they both use.
You import all of its settings in one line, and then only write your like a name customization or another stuff, like defining the actual instances without duplicating every setting in every instance.
Got it.
This is the instantiation of one of those classes, basically, that we refer to. If you look at it from that level.
Yeah, that's a good point.
Awesome.
So that's a perfect segue into the next thing I wanted to talk about, which is borrowing also from established conventions in other languages, are mix-ins. And this was a realization we had recently. I think Matt Calhoun brought it up. And we are defining, we've realized we've been doing this. We just didn't, we didn't call it maybe this. And I think by now, identifying that this is what we are doing, we can double down on the pattern and formalize how we do it in our tooling and in our modules and so forth. And that is the concept of mix-ins. So with mix-ins, you're basically defining some reusable logic, some reusable code in a centralized place that we can pull in anytime we want that capability. And in Terraform, there's no native support, obviously, for mix-ins. But what we can always do is copy a file from somewhere and drop it into our current working directory. So we are doing this already with our null label. So the null label module exports a file called context.tf. And we copy that file in as a mix-in in all of our 180 Terraform modules. So we define and establish a consistent interface with name, namespace, tenant, and all those things in every one of our modules. A similar use case for mix-ins is security groups. So for every module that you have that exposes some resource, network accessible resource compatible with security groups, you probably want to have a standard interface for how you use those security groups. Now, The security group example I bring up here is a little bit of a sore spot. We need to do some work to standardize this in such a way that is a literal drop-in replacement as it is for context. So context is a literal drop-in file. But for the security group file, I believe Jeremy on our team was saying there's some post work that has to be done after dropping in this mix-in. And this is where tooling comes in. So as those who've been working with Cloud Posse and in our community for some time, you're familiar with a tool that we have called Atmos. And Atmos is a command line tool that we use to help facilitate a lot of the management of infrastructure for multiple tools, be it Terraform, Helm file. We want to add support for Packer and other tools as well. So with Atmos, one of the things I'd like to add would be native support for how to work with mix-ins for any language, for any system, because the concept of pulling in files and dropping them in is a reusable pattern across tools, not just Terraform. Any questions on mix-ins? All right. Let's jump over to this tool was dropped. I don't know who gets credit for this one. I've seen like 10 messages in my different news feeds related to this tool that's come out. The maintainer of this is in the sweetops Slack community, so that's really cool. If you have any feature requests or questions, I'm sure you can reach out to him. So Terraform module versions is a tool that helps you kind of understand what module versions are used, which is easy, right? You can just look at your log file. But more importantly, what is the latest version available which matches your constraints in your provider's configuration? So it makes it easier to see if you want to update this. There are many other ways to do this, but I think this tool presents a nice way. There's like the TF update command by Miyojojo. Excuse me for screwing that pronunciation up, but he has a lot of helpful tools, including TF migrate and this TF update command that does something similar. It looks like this tool is also still being well maintained. Update 6 days ago. So the this Terraform Terraform modules command. We're adding to the Cloud Posse packages distribution. I don't know if the pull request was open yet by RB, but yeah, I think we do have the issue open for it. Or maybe it already merged. Let's see. Terraform. Yeah, it already merged. So we're already distributing this via our Cloud Posse packages distribution. If you're not aware of what the Cloud Posse packages distribution is, it's a couple hundred tools, I think, at this point that we use in the execution of our work day to day. And since we struggled to find a centralized place that was updated, that had the latest versions, that we could install on Linux, on Windows, on Mac, or just through random make targets, we decided to implement it this way. However, as you'll see here, what's also pretty rad is RB on our team has taken it upon himself to implement a custom homebrew tap now. So all of these packages that we've been syndicating will also be available via the Cloud Posse homebrew tap as well. And to be clear, all we're doing is syndicating already existing packages. We're not rebuilding them. We're not going through all that hassle. Cool. Any questions on the Terraform module versions, Clive? Moving on. Let's see. We got 20 minutes here for questions. Andy, thanks for going through Slack and pulling some of these out. See, Max, you had a number of questions here. Max, you want to ask the first question here?
Yeah, so the gist of all of my questions is basically, is there still a place for third-party database vendors inside the AWS landscape, excluding the legacy deployments that they still support? Like if I was about to deploy a super high load, high performance distributed database today in AWS, are there any considerations except the Aurora or like their native solutions?
There's like MemSQL, for example.
Yeah, I didn't hear about it.
They
So
renamed to a single store. I didn't see that.
That's
yeah.
why I bring this topic, because really I wasn't sure if there's really still any development going on for these types of products, and are they still superior to Aurora, or are they just a niche?
I think it's a hard question to answer generally, and without knowing the answer specifically, I would argue that it's the existence of these vendors relies on them tackling one niche, one demographic, one use case, and doing it better than the general purpose use case. So like, for example, maybe a SQL database specifically optimized for time series or something. Would it be the best database for everything else you want to do with SQL? Probably not, but it would be maybe the best SQL implementation for a time series data set. And I think that goes on for a lot of these providers.
Yeah, but my use case was more about, it was not so niche. It was just about high write through output and high and low replication. Like this is what my friends were are facing in their company right now, and they are actually somewhat looking to a CockroachDB deployed over EKS or EC2 to solve this, and they have an issue with Aurora. So I was arguing that they will never get the better numbers from those solutions rather than the Aurora itself.
Yeah,
and they are still pursuing to try something like this. So I was just, I mean, am I missing something, or just, or are they missing something?
Well, and then it's also the trade-off, right? Like, okay, so they met their requirement, shaving off a few more milliseconds, but now they have the overhead of the system that they manage that's in the critical path of everything. So, and that failed upgrade takes them out for 3 hours. Now, shaving off 3 milliseconds, was it worth the 3-hour outage? Perhaps it is. Perhaps the amount of money on the line is so significant. Or the 3 milliseconds adds up to way more than 3 hours for that period of time.
Yeah, I was expecting to hear some opinions about Cockroach or Percona, because these are long-living vendors and they are well respected in the community. So I might hear someone saying, like they are given a great support in AWS and are still superior to some of the AWS products. So, but I don't hear that at all. I just see everyone migrating into AWS native, especially since they did Aurora. But I mean, another like a fourth question here is a little different viewpoint on this. Is are there any proxy products that may improve some of your Aurora aspects? Like, does anyone use any proxies on top of Aurora to do anything useful? Because we also been playing with I don't recall like the actual name of Postgres proxy, but it was supposed to scale reads for us because it does caching or something like this. But in fact, it was just it broke all of the queries for us, and we faced some tons of errors with it, so got rid of it eventually. So are there still any like anyone knows about any proxy that bring any value? Pepe was mentioned something in Slack, but he didn't specify anything particular.
And to call out the obvious, because I think you're not asking about RDS proxy by AWS. You're asking about like open source alternatives.
Yeah, I saw that the RDS proxy does make sense for that use case. They did it because, I mean, obviously if that was possible on the backend, they would do it on the backend, but they did it in the proxy because that was their exact use case. But for various like random products on the market, are they still making any value on top of Aurora? Like, are there at least one use case that could make it make you use it instead of native solution?
Anyone want to chime in on this one? Or any of the other related questions? Basically, how do you squeeze out more performance out of RDS Aurora, or should you even consider other alternatives like CockroachDB or Percona? Like, I'm really curious about Percona. I mean, Percona must live on because of still the number of entrenched companies with massive on-prem databases. But for companies that have broken free of that, I mean, what is Percona's response to the movement towards managed
Percona's
databases?
still doing a lot of on-prems, which run on bare servers. That's their main targets. But in AWS, I didn't see wide adoption.
Yeah, although I know that a lot of people have also adopted that. What is it called? XtraDB, their storage engine for MySQL as an example, and it does a lot of things with like clustering and a little bit better replication and a bunch of things that that NODB doesn't do, and that's why the purists out there, I guess, that have adopted it have raved about it for so long. I just haven't seen a lot of it since the cloud-based native versions of like MySQL, et cetera, have gotten much more popular to deploy, like Aurora and RDS out there. So it'd be interesting to see what their current download numbers are, you know, for like Percona as an example.
Yeah.
I have more experience with on-prem. In this problem set, I'd be looking at something like, you know, load balanced read replicas or whatever. Is that something to look at, or?
Yeah, Aurora also has read replicas, and they seem to have a decent latency. And I bet you cannot improve that by running this on EC2 yourself.
But what you'd really want is like an intelligent proxy that would be able to redirect the request based on the replica that is least, or you know, the most performant.
Something like this. Also, the question was for quality of service in Postgres, like a prioritization of particular queries. Because I didn't see that. I mean, I've never seen that for Postgres at all, and maybe there is a proxy that can do this, but that would be possible. But still, it's an emptiness, not on the AWS roadmap, not on the third-party market. So
yeah. So Michael is asking, you know, is there a good pattern or any good resources for how to work with Terraform without any wrappers, kind of work with native Terraform? So no Terragrunt, no Atmos. Maybe what this really means. So I think the God honest truth is, even if you don't use native, even if you're going to use native Terraform, you're probably still going to want a task runner. Because the commands get pretty boring very quickly. So whether you're going to use GoTask or Mage or you know, make files or Atmos or Terragrunt, I think that's in the end what you want. But so moving off of Terragrunt, what are some good resources to learn how to split up Terraform workspaces for infrastructure is what Michael is asking. So I'm curious, Matt, do you know of any like guide published, like this is if you ever wanted to break out of Terragrunt, this is the guide for breaking out.
I don't, but my first inclination is to answer every folder that you currently have in like your Terragrunt infrastructure like repo. Probably turns into a workspace.
Yeah, that's true.
That's probably the TLDR. Like a
workspace that is path aware, like a workspace that is relative to the path.
Yeah.
So
obviously, you're gonna have to refactor some things because like Terragrunt isn't going to make you have like a root module or a component, like, down there. So you're gonna have to build like some of those, probably to invoke a lot of things that that Terragrunt is doing under the hood for you, like kind of auto magically.
Also
The
was wondering
other
that.
nice thing is that ultimately all these states are just files in an S3 bucket. So once you come up with your convention, you can script something relatively easily to move those files around. And we've had to do that at Cloud Posse as we've switched conventions for how we manage state. We've had to come up with our own scripted migration tools for that. You're going to say something, Max?
Yeah, I'm not sure if in other discussion, but what's that particularly bad in Terragrunt that you want to move from it? I mean, you can still
what's
do
the
a single,
problem you're trying to solve? Yeah.
You can still do single repo with Terragrunt and reduce that release burden, or do some other versioning schemas that are different but still using Terragrunt. So maybe easier for you.
Yeah. And if I were actually taking on a project of infrastructure of any significance, I would probably think about like standing up like parallel things and migrating resources over there where possible, like doing all this Terraform state moves and all that kind of thing. Once you do this, if it's a literal like migration, seems like you're going to spend a lot of effort for something. If it's truly like cat hole and not a pet, you could just stand up a new one with your new module and transfer your service over onto it and not worry about it.
Yeah, but on the other side, you're entering on the potential endless migration path, which I'll send to me previously. So.
Michael, are you on the call? Do you have any other questions on this?
I don't see him here on our list.
Okay. So I wanted to jump to the next question then here. Zach Lober asks, are any teams out there using conventional commits? And I think I know what this is. Yeah, so I'm happy. I'd like, before you hear my spiel, I'd like to hear from others who are practicing this level of Git hygiene with conventional commit messages like this.
I've worked on a few projects that use this, and I'm actually a pretty big fan. Although I don't think it necessarily plays all that well with Terraform type of things, but it's more for traditional development, like web development. Mm-hmm. And you also have to be careful when you're doing like squash commits, as an example, that you pull all the relevant messages you want from those commit messages like into your pull request, so that you can actually see everything that was done like along the way, especially if you do multiple things in a single pull request.
And yeah, disabling any squash commits, or maybe you said that, but
yeah,
that would invalidate this whole approach. And let me just set up for everyone else who might not be aware of this. So the problem that's trying to be solved here is that when you look at the commit history for any repository that you have in your organization, the hygiene of the commit messages, if you're not doing squash merge commits, could be pretty atrocious. It'll be like, fix me, test, update, update. And they're just, it's garbage when you look at it. It's not helpful for anyone looking through it. With this convention here of the conventional commits, the idea is to clean that up, assert what this commit is doing, what you're committing to in this line of code change. And the onus it puts on the developer is, well, inevitably you're going to be, if you're doing infrastructure as code, as what Matt's saying, you're going to be having to make lots of commits, often push it up to your CI system to have it tested out if you're using Terraform Cloud. And then once you finally have all that working, then you're going to have to go back to your commit history, probably in your IDE, and rebase your commits so that they're grouped nicely into these beautiful conventional commit messages. And fundamentally, love it. Beautiful. Everyone should do it. Now try and do that in an open source project or community where you have no control over the developers who are doing it. And in any larger organization, just beating this in, it puts additional overhead on the organization to try and implement these things. So as much as I love it, I see it as a difficult thing if it's if you don't have full control over the supply chain of all the commits.
Yeah, the one place that I've seen it work like with this is that there are for multiple languages out there, there are pre-commit hooks that you can run to make sure that your commit messages like follow the standard and all that, and then you don't you basically just like enforce it. Like it's easier to do that way, and it takes a little while to get used to it, but then once you do, it it becomes second nature. And for sure, it's a lot easier to see like what changed when by scanning commits and all those things. But it definitely takes overhead. And I've never seen it work successfully in an IEC project.
I think, yeah, go ahead.
In defense of conventional commits, they talk about what Eric said with, if it's an open source project or whatever. And it's basically, people in a PR can do whatever commit messages they want. It doesn't matter, because when you merge the PR as a maintainer, you're going to squash and you're going to write the commit message.
If you're doing squash commit, then then you have.
If you're doing squash commits, and then it's just you got to do squash commits, right? I mean, which I like squash commits anyway, so that doesn't bother me. But
So that basically builds to what I was going to suggest. And maybe this is what they, to your point, Andrew, they're suggesting that, well, instead of just doing squash commits, and instead of your squash commits just being your pull request title, which is what we have by convention here. So if you look at our commit history, I'd say they're pretty clean. But they're saying then to introduce also this convention on possibly your pull request titles, or at least the commit message on your squash commits. Is that accurate then?
The convention would be enforced on the commit message of the squash commit.
Yeah, okay, I can stand by that more.
And you can, I don't know if GitHub really does it, but I know for GitLab for sure, if you're paying for it, you can enforce it and have push rules.
Mm-hmm.
And I'll caveat all this with, I'm not a huge fan. I commented on the thread that a couple of teams have tried it, and it's just been friction for the most part, and it's been people kind of complaining about why are you making me do this extra thing? It's one extra thing on top of a million things that I got to do, and I hate it.
Yeah.
I bet they say that about writing documentation and tests.
Oh yeah, absolutely. Every day. Writing
it's
documentation,
the universal
tests,
escape hatch. Yeah.
All of that stuff, and that's one of the ones that I think you can let go, and when you have to pick your battles, and it's like, no, we will do good documentation, we will do good tests. Okay, we can let this one go.
I think not squashing your pull requests before merging is like not using feature branch at all. You just throw in a lot of garbage in your master branch, which really doesn't bring any value, because you cannot really revert to any of those commits. You have to revert all of them because they are a single feature. So it's I see no point at all. And also for the enforcing like the format of commit message itself, like, well, is there really any value in it? Did you really ever was looking for something through looking at
did it really solve a problem that you didn't?
You never do this. You always do git blame, and then you go to a pull request that is referred in a commit message and read the thread in a pull request. So
yeah,
I mean,
the reason to do this is that it automates the creation of the changelog. Right.
Okay, yeah.
That's the reason to do this.
Yeah,
Is that you get an
that's what I was
automated
gonna say.
change log.
That's a great point. Yeah, I agree. But that has to be what's in your change log is what's in your pull request description. That's what we did in the past. So you have to really keep your pull request description like cool.
And it's,
It
not
also
the
in a
commitment.
large system that has a lot of different components, it also helps you very easily scan and see when was the last time that the foo component was touched. Like you can very easily do that, which it is not easy to do through Git history and Git blame and all of that kind of thing. Otherwise, if you just scan your commit messages that way.
All right, everyone. Well, we are out of time for today. I just wanted to end with a big thank you to everyone for participating and sharing your questions and answers today. If you want to catch up on our past sessions, head over to youtube.com/c/cloudposse. Again, that's youtube.com/C/cloudposse, and you'll see our past sessions there.
I'm gonna actually just really quickly. YouTube recently made it so that you don't need the /C anymore, and
What?
they
Really?
will automatically redirect to the channels. Yeah.
Oh,
I
that's
just
cool.
happened to see it the other day. So
That's cool. I'm gonna try that out because I didn't like having to have that extra slash there. But
for sure, youtube.com/cloudposse works, and it automatically redirects to /C/cloudposse.
which automatically redirects to
Yeah.
the crazy cryptic code. Okay, good to know. I'm gonna update the slides for next time on that. You heard it here first. No, if you haven't yet joined our Slack channel for our DevOps community, head over to slack.cloudposse.com. We got nearly 5,000 really awesome people there, being very supportive, very friendly environment to start your journey working with our Terraform modules and ecosystem. If you haven't yet registered for next week's office hours and you want a calendar invitation, you can head over to cloudposse.com/officehours. Again, that's cloudposse.com/officehours to get a email invitation for our next session. We host these calls every week at 11:30 Pacific. Hope to see you next week. Same place, same time.